We introduce a new class of linkage mechanisms called conformable mechanism, in which joints and links conform to a freeform surface in one of its configurations. A conformable mechanism can accomplish complex motion transfer tasks when deployed and be stowed compactly when not in use. Modeling conformable mechanisms. The topology of a conformable mechanism is defined by the permutation of joints in the linkage mechanism, where the joint has three types: revolute joint, universal joint, and spherical joint. Here we show three example topologies of a 1DOF conformable mechanism with four joints. To model the geometry of a conformable mechanism, we first parameterize the freeform surface that the mechanism conforms to, called the reference surface. We model the shape of each moving link as a 2D B-spline in the reference surface's UV space. In the conform configuration, the center point of each joint and the center line of each link have to be exactly on the reference surface. However, the reference surface has to be cut to avoid collision with the moving joints and links. To ensure a fabricable surface, we propose an approach to automatically remove disconnected patches and fragile features from the surface. Designing conformable mechanisms. Taking a target motion and a reference surface as user-specified inputs, we develop an optimization-based approach to design a conformable mechanism that approximates the motion while conforming to the reference surface. Our optimization allows finding a trade-off between approximation of the target motion and preservation of the mechanism appearance in the stowed state. Results: our conformable mechanism is able to conform to a reference surface with a variety of freeform shapes. Our conformable mechanism can have different mobility types: extramobility, intramobility, and tram-mobility. Our conformable mechanism can generate a path that precisely passes through three target points and approximately passes through four and five target points, respectively. With six target points, the performance of path approximation gets lower. Increasing one joint in the mechanism improves the path approximation performance. Our conformable mechanism can generate a 3D motion that precisely follows two target poses, and a 3D motion that approximately follows three target poses. Applications: our conformable mechanism can be used in a mechanical toy to drive the motion of a character while conforming to the toy roof. And a ceiling-mounted manipulator for performing pick-and-place tasks. And a mobile robot for controlling the motion of a tool to perform agricultural tasks. Fabrication: we design a conformable mechanism to generate an 8-like 3D path and fabricate the mechanism with 3D printing. The 3D path generated by the physical prototype is close to that of the virtual counterpart. Thank you.